Kepler is unique among space telescopes. Unlike the Hubble, which turned its gaze far and wide and sent back stunning images of the cosmos, Kepler is designed to stare fixedly at one small patch of sky, taking the same snapshot day in and day out for years on end. It began, as with any new telescope, with what astronomers call first light.
Kepler's first light image came down to us at NASA Ames about 24 hours after we ejected the disk cover. As it filled my computer screen, the image that came to my mind was like champagne filling a glass, with all of these stars being the little bubbles. It was very exciting. Every single tiny dot that you see is a star that is in the field of view of Kepler.
Kepler is focused on a small patch of sky near the constellation of Cygnus the Swan.
In that area of sky are 4.5 million stars in our galaxy alone.
But Kepler isn't looking for stars. It's looking for planets that orbit the stars. But that's a problem, because Kepler can't directly see planets. Planets are much smaller and dimmer than stars. They get lost in the glare. So Kepler is looking for something called a transit, which occurs when a planet passes in front of the star. As it does so, it dims the light by a fraction. That dimming is what Kepler is designed to detect. It's a principle that can be illustrated with a distant tower and a spotlight.
Okay, let's imagine that there's a moth flying around that spotlight. Could we ever hope to see the moth? No way. The moth, although it does reflect a tiny bit of the spotlight's light, it's far too feeble for us to see that.
Since the light reflected off a planet is typically 10 billion times fainter than the light emitted by its star, detecting a planet might seem impossible. But Kepler has a way around that problem.
If the moth passes in front of the bright light, a little bit of the light that was going to reach us obviously gets blocked by the moth. Then we are able to detect the moth by measuring very carefully that very subtle change in the total brightness of the spotlight.
The bigger the moth, the more light it blocks, and the more the light dims.
In exactly the same fashion, that's how we can detect small planets orbiting other stars and even measure their sizes.
That's Kepler's primary mission, to watch thousands of stars for signs of a transit. Scientists plot the brightness of each star in Kepler's view on a graph to see how it changes over time. This is an actual plot of one star over 2 weeks. Sure enough, every 3 days there's a tiny dip in brightness, revealing a planet orbiting this star once every 3 days. Just like the moth, the bigger the planet, the more light it blocks. In this plot, a huge planet transits in front of its star, causing a much larger dip. Even though scientists speculate about how life might survive on truly alien worlds like this, most still believe that our best hope of finding life that we might recognize lies in finding a rocky planet, a similar size to Earth, that orbits a sun more like our own. It's a challenge of astronomical proportions.
A planet as tiny as an Earth transiting across the disk of its star is going to produce a change in brightness of just 1 part per 10,000. Imagine the tallest hotel in New York City, and everybody has their light on. And one person in this hotel lowers the blinds by about 2 centimeters. That's the change in brightness that we're trying to detect from the transit of a planet as small as an Earth passing in front of a star the size of our sun.
So Kepler scientists scour the data for signs of a truly tiny dip, evidence of an Earth-like planet. And they find something promising around star KOI 701, 1,200 light years away. The Keck telescope confirms that there are at least 3 planets orbiting the star.
The third planet out, that planet is in the habitable zone. But it's also large, like 22b. It's like Kepler 22b. It's, probably a water world.
The team was about to go public when something extraordinary happened.
So 701.03 was done. In the bag, nice ribbon tied around it, ready to go off to the publisher for publication, when we got an email from one of our team members telling us that he'd spotted what looks to be another interesting signal in the data.
What Natalie's team member had spotted at the last moment could turn out to be one of Kepler's most exciting discoveries. It looked like KOI 701 didn't just have 3 planets orbiting it. There were 4. And this new potential planet was in the right place and the right size.
We examined the data more carefully, and there is another planet that is smack in the habitable zone, and it's only a little bigger than the Earth.